All right, let's dive right into this. Welcome to today's Explainer, everyone. Today, we're popping the hood on a piece of tech you've probably heard a lot about, but maybe haven't really looked at on a molecular level. I'm talking about the hydrogen fuel cell. It is literally at the center of some of the most exciting shifts in clean energy, and we're going to break down exactly how this thing ticks. So, let's get into it. Today, we are demystifying the hydrogen fuel cell. So, what if you had a battery that never died? Think about that for a second. A battery you absolutely never had to plug into a wall for hours on end to charge up. Sounds kind of like science fiction, right? Because, every device we own is constantly reminding us that energy runs out. But what if we could completely rewire how we think about generating that power? Well, that brings us to the big idea here. Imagine a power source that never runs out, with one simple caveat: as long as you keep feeding it fuel. And the truly crazy part, the only fuel it requires is just hydrogen and oxygen. Oh, and when it's done doing the heavy lifting of powering your car or your home, what does it spit out? Pure, clean water. It's a beautifully simple concept that could honestly change everything. Now, to really grasp this, we have to reframe the fundamental difference between what we know and what a fuel cell actually is. Think about your normal, everyday battery. A standard battery is essentially just a storage box, right? It holds a strictly finite amount of chemical energy inside itself, and when it's empty, it's dead. A fuel cell, on the other hand, doesn't just store energy. It continuously produces electricity on the fly by combining external fuel with the air around it. It is way less like a storage container and actually much more like a mini factory. Section 1. Inside the fuel cell. Anatomy of the machine. Let's start with a really clear definition. A fuel cell is a device that converts chemical energy directly into electrical energy. And the absolutely crucial element here is that this happens completely without burning fuel. There is absolutely no combustion happening here. No fire, no mini explosions like you'd find in a standard internal combustion engine. It basically acts as a tiny, highly efficient power plant that entirely skips the noisy, messy process of burning things. To make this direct conversion happen, the fuel cell relies on three main physical parts. Basically, the three main characters of our chemical narrative. Number 1, the anode, which is the negative side of the cell. Number 2, the cathode, which is the positive side. And number 3, sitting right smack in the middle, the electrolyte, which acts as a membrane. Honestly, if you lock these three parts in your mind, you've got the blueprint for the entire technology. Section 2. The electron's journey. The chemical narrative step by step. We can actually break this complex chemical ballet down into three really digestible steps. Step 1. Hydrogen enters the system. Step 2, electrons take the wire. And Step 3, oxygen arrives on the scene. Let's zoom into the microscopic details and see exactly what is happening at each of these three stages. All right, Step 1, hydrogen gas gets pumped into the anode, that negative side we just talked about. But here's the thing, hydrogen molecules are super stable, and we need to break them apart to extract that energy. So they run into a catalyst, usually made of a precious metal like platinum. This catalyst acts like a molecular wedge, literally splitting the hydrogen molecules into two distinct pieces, positively charged protons and negatively charged electrons. Now, both of these particles really want to get over to the positive side of the fuel cell, the cathode. But standing right in their way is our middle membrane, the electrolyte. And this is where the sheer genius of this design kicks in. The membrane is highly selective. It happily allows positively charged protons to pass right on through, but it acts like a brick wall for the negatively charged electrons. So the electrons are stranded, but they still have this massive magnetic urge to get to the other side. Which brings us to Step 2, the big aha moment of this whole explainer. Because those electrons are blocked by the membrane, they're forced to take a detour. They have to take the long route, traveling through an external wire to reach the cathode. And guess what? A flow of electrons moving through a wire is literally the exact scientific definition of electricity. By forcing these tiny particles to take a detour, we generate the electric current that can power motors, light up homes, you name it. Finally, we hit Step 3. Over on the positive side, the cathode, oxygen from the outside air is breathed into the system. So the protons that snuck through the membrane arrive. The electrons that did all the heavy lifting traveling through the wire arrive, and they all reunite with the oxygen. When you combine hydrogen protons, electrons, and oxygen, they chemically bond to form H2O. Yep, water. Along with a little bit of heat is the only major byproduct of this entire incredible process. So when you take a step back, you really see how elegantly simple this entire reaction is. When you add it all up, the overall reaction is just Hydrogen plus oxygen results in electricity plus water. We have taken two wildly abundant elements, generated usable electrical power without burning a single thing, and the exhaust pipe drips clean enough water that you could theoretically drink it. If it helps, think of a river. Water naturally wants to flow downhill because of gravity. If we drop a turbine into the middle of that river, we can extract energy from that natural flow. Well, the fuel cell works exactly the same way. The electrons naturally want to flow to the positive side. We put a wire right in their path, and we extract electrical energy from that natural chemical flow. It is fundamentally just harnessing nature's movement. Section 3. The Future and Challenges. A reality check. So you might be wondering, if it's this perfect, why aren't all of our cars and homes running on hydrogen today? Well, when comparing normal internal combustion engines with fuel cells, a normal engine turns fuel into heat through explosions and then tries to harness that heat into motion. The flaw there, most of that energy is completely wasted as heat just escaping into the air. A fuel cell skips the heat phase entirely. It goes from fuel straight to electricity, and that makes fuel cells vastly more efficient than traditional combustion engines. The theoretical advantages of pure hydrogen fuel cells are nothing short of incredible. You get that sky-high efficiency we just talked about. You get totally quiet operation because there are no clunky moving engine parts. Your only exhaust is pure water, meaning literal zero greenhouse gas emissions at the tailpipe. And unlike a battery that forces you to stop and wait to recharge, you get continuous operation. You just pump in more hydrogen like you would gas at a station, and you keep going. However, we definitely have to look objectively at the roadblocks holding this technology back right now. First up, while hydrogen is the most abundant element in the universe, it loves to bond with other things. Separating it into pure hydrogen fuel requires a massive amount of energy, which makes production pretty expensive. Second, hydrogen is the lightest gas in existence. Trying to store it safely and densely enough to fit in a car requires incredibly advanced high-pressure tanks. And third, remember that platinum catalyst that splits the hydrogen? Platinum is a highly expensive precious metal. When you combine these three objective realities, it explains exactly why battery electric vehicles currently dominate the clean energy market. They are simply cheaper and easier to manufacture at scale right now. But the potential remains absolutely staggering. To quickly summarize the brilliant mechanics of how this machine makes electricity, just remember these 4 steps. We split hydrogen molecules. We use a membrane to block the electrons and force them through a wire. That forced detour generates our electricity. And finally, we recombine everything with oxygen to safely produce water. I want to leave you with this final inspiring thought from our source material today. Quote, inside a fuel cell, the same reaction that forms ordinary water can be harnessed to power cars, buses, and even spacecraft, all by guiding tiny electrons through a wire. It's such a great reminder that some of the most powerful solutions to our global challenges are hidden right in the basic chemistry of nature. The technology works, but as infrastructure and green hydrogen production race to catch up, the real question is, will fuel cells eventually dethrone the lithium-ion battery, or will they be relegated to niche industries forever? Something to think about. Thank you so much for joining me on today's Explainer, and keep learning.